Hello, welcome back to Apostle 1 Tutorials. Now today we are coming to look at this question, but make sure you tap on the subscribe button, turn the notification bell on so that wherever or whenever I upload a video, you'll be the first person to get it. Okay? Yes. Now let's move on. Now you can see this one is logarithm, indices and logarithm. Yes. Now how are you going to solve this question, a question like this? Now, I can express this one in this index form. I can express 16 in the form of index or in the form of indices. So 16 is the same as, I want to change the base to base 4 or base 2. Okay, let me change to base 2. So the same as 2 exponent 4 will give us 16. It depends on how you want to solve. You can change it to an index form, either to base 4 or anything. Yes. But I think I want to use the simplest way you can use to get this particular question correct. Okay. So the 16 is same as 2 exponent 4. So this one is same as 2 exponent 4, all having another exponent which is log 2 base m. This one is equals to 8m. Now back to law of indices. When you have 2 or when you have m exponent n, all having an exponent of x. What does it mean? From the law of indices, we said that the s will come and multiply the n. So it's the same as n times x, which will give us nx. So the same thing here, it means that the 4 will multiply log 2 base m. So we're going to have 2, the 4 multiplying log 2 base m will give us 4 log 2 base m, now equal to 8m. Now, so to make it very simple, the only way we can solve this one is to either we take natural log of both sides or logarithm to both sides. So I'm going to take logarithm of base 2 to both sides. Now taking log of base 2 to both sides, it means that we multiply here by log of base 2, multiply here by log of base 2. So it means that I'm going to multiply here by log of base 2. No, it's okay. Let me continue from here. Multiply here by log of base 2 times this one. Multiply this side too by log of base 2. Now, from here, from our law of logarithm, if we have log of a exponent n, we can bring the n at the back of the log, which is the same as n log a. Now the same way, we have log 2, and the 2 is having an exponent of 4 log 2 base m. So I can bring 4 log 2 base m at the back of the log. So I'm going to get this one at the back of the log. We're going to get 4 log 2 base m and then log 2 base 2. That is how I want to make it. Log 2 base 2 will give us 1. Now at this point, I can split this one into 2. You know, from the law of logarithm, if you have log a and b, is the same as what? Addition of log a plus log b. So because of that, I can treat 8 and m as different variables. So this one, 8 and m are multiplying, so you can expand this one into log 8 plus log m, because 8 and m, they are multiplying, just like a and b multiplying, so we can make it log a log b. So applying that here, we can make it log 8 base 2 plus log m base 2. Now from here, log of the same base is 1, so log 2 base 2 is 1. So we're going to have 4 log 2 base m equal to, now let me write this one in an index form. where the base is 2. So 8 is the same as 2 exponent 3. Yes. So we have 2 exponent 3 here, base 2, plus log m base 2. Now, if I look at this one has a base of m. This one has a base of 2. So I can change the base here so that the base will be 2. Just like this one. So let me change the base. Let me change the base. So change of base. How do we change base? If I have log a base b and I want to change the base to log a, it will be 1 divided by log, then you change the base, log b base a, from the law of indices. That is how we change the base. 1 over. There are more to this one, but I'm going to treat this one separately in a different video. Yes, when I tackle the logarithm and indices. So watch out for those videos. Now, so it means that we have 4. Then I can change the base here, 1 over log m base 2 equals, I can bring the 3 at the back of the log, so we have log 2 base 2 plus log m base 2. Now log of the same base is 1, so this one give us 1. Now so from here, this one times this one will give us 4 divided by log m base 2 equals, log of the same base is 1, so this one gives us 3 plus log m base 2. Wow, this is what we've gotten to. Now I want to clean here, then I continue from here. Now, I think this one will lead to quadratic equation, so I'm going to do substitution. Let y be equal to log m base 2. So wherever that I see log m base 2, I'll put y there. So which means this side will be 4 over log m base 2, which is y, equal to 3 plus log m base 2, which is y. Now I can multiply through by y. I can clear fraction multiply through by y. So we have this one times y will give us 4. This one times y will give us 3y. This one times y will give us y squared. So this becomes a quadratic equation. So we have to solve for the value of y. Let me rearrange it. We're going to get y squared plus 3y. This one will move the equation and become minus 4 equal to 0. Now then we factorize to get a value for y. So how do we factorize? Two numbers that when you multiply, you're going to get negative 4. The numbers are negative 1 and 4. So when you multiply 4 times negative, we're going to get negative 4. When you add negative 4 and 1, you're going to get positive 3. So we can use this number. Now this is quadratic. Go back to quadratic equation and go and revise. So this one is so simple. We're going to get m in one bracket, another m equal to what? 0. These are the numbers we are using. This one is 4, so here will be plus 4. This one is 1, so here will be minus 1. Now this one means this and this multiply to give you 0. So the first answer is, okay, we are using y. So we have y and y. So equate this one to 0. Y plus 4 is equal to 0. Y is equal to minus 4. And then another one is we equate this one to equal to 0. Y minus 1 is equal to 0. Y is equal to 1. So we've gotten two answers for y. One is negative, one is what? Positive. So let me check the first one. You have to use the value of y to get the value of m. So let me check the first one. When y is equal to negative 4, we have y is equal to log m base 2 from this side. So I'm going to solve that y is negative 4. So we have negative 4 is equal to log m base 2. So what we can do is that we apply the law of logarithm. When we have log a base b is equal to, let's say, y, this b will come and raise the y. So we're going to get a is equal to b exponent y. So we apply that one here. Yes, we apply that one. So this means that the base 2 will come and raise the 4. So we're going to get m. Okay, let me start from here. This one will come and raise. It's going to get 2 exponent negative 4 is equal to m after finding the antilog. So what will be m? 1 over 2 exponent 4. That is when you apply the inverse rule. If you have exponent negative n, the same as 1 over a exponent n from the inverse rule of indices. So what we're going to get, our m is equal to 1 out of 16. That is the first answer for m. First answer for m. Now the second answer for m, that is when y is equal to 1. When y is equal to 1. So let's move on. When y is equal to 1, we have our y is equal to log m base 2. So we use the substitution. Y is 1, so y is 1 equal to log m base 2. We use the 2 to raise the 1. So we're going to get 2 exponent 1 is equal to m. Then our m will give us 2. So therefore the value of m is 2 and 1 out of 16. 2 and 1 out of 16. And this one ends the answer to this particular question. You see that it's very simple. Copy it, go through again, and then you'll be good to go. We are just applying the law of logarithm and indices. It's very simple, but I will take this one as a topic and then I'll treat all of them. So watch out for more videos.